Welcome back. Let's talk about algorithms today. The word algorithm might mean complexity to you. Don't be frightened by the word algorithm. We are not covering any complex algorithms like searching or sorting algorithms. Some of these algorithms can be complex because they use more complex data structures as well. We'll cover some basic algorithms to do small programs. Algorithms are the steps needed for a computer to execute a desired function. They represent the program logic. A bigger system or a program needs to be broken down to smaller pieces to implement it better. These small pieces are called subsystems or modules. These modules may be written by different engineers. Before they start coding, they need to understand the requirements very well. Each module writer will develop their algorithms or procedure or steps to implement their program. Every computer program can be broken down into three aspects: input, process, and output. When you try to solve a problem or write a program, always remember this. Input represents what is needed for writing the program. It falls in various categories. For basic programs, you will read the values from the keyboard from the user. When you interact with a shopping application like Flipkart, you give an input and the app processes your input. In some cases, you will get the input from a database or a file. So Flipkart, for example, obviously the input would come from the user and also from their database. In some cases, when the program is complex, a part of the program or another module can also give the input to your program. Similar to the input, output also can be represented in different ways. It can be printed on the screen, but for complex systems, the output can be input to another piece of code, or it can be written into a database or a file, so there could be different representation of the output. We'll focus more on process today. Algorithms are written to represent this process part. To summarize this, process takes inputs from procedures. The process takes inputs and produces outputs. Algorithms are usually written to cover this process part of all the computer programs. Let's take a small problem and see how do we write an algorithm corresponding to it. The problem here is very basic. We have to find a largest number. A list of numbers are given to you. So what is the output needed? It's the largest number from these numbers. And what is the process? It's to find the largest number. So there is a way we should be able to find this. So this is easy for human beings, but for a computer, we have to explain clearly to the computer how do we do this process. So input obviously is the numbers which is given. In the beginning, it's a good idea to write a pseudocode to understand how to solve the problem. So pseudocode is not the code. It doesn't follow any programming language construct. It need not be like a C program or Python program or a Java program. It should be human readable. Anyone who is going through this should be able to understand what is the logic. So to start with, let's see how do we do this. So we can maybe assume that largest as 0 because we know 0 is not the largest. And we compare each number with the largest. And if that number is greater than largest, we make the largest as that number. So for example, we compare 0 with 80. And since 80 is largest number, so the largest become 80 in the next step. And then we compare 100 with 80. So largest become 100 and then we just keep going. So the process here, so it's written more like English paragraph. It doesn't have steps. To convert this into a computer program, it's a good idea for us to give some steps. So what was the step 1? We initialized the largest as 0, and also we initialized a counter which is I is equal to 1. In the step 2, we compare each number with the largest, and if the largest is higher, so we just say that we compare each number with the largest, and if the largest is greater than the number, we assign the largest as to that number, and then we increment I, and then we repeat the step 2 till all the numbers are compared. Why do we write this in this fashion? Since we have this repetition, so we know that this one will go into the loop, and this is the initialization, etc. So it would be easy for us to convert this into a computer program. So in this case, the issue is that we will not be able to say how do we write a loop. We don't know which is the step to go back to. So this is the fundamentals of a pseudocode. So we should write this into step 1, step 2, etc. to clearly distinguish the statements. So these are statements and this is a loop. So to test your code or to make sure that your pseudocode is correct, you have to check it with different input values. So what if your input value is, or the input values are -1, -2, -3 and -4, all negative numbers. So what our process was, we started with largest as 0 and we compared that with each and every input value. So since none of these are larger than 0, your program would give your largest number as 0, which is wrong. So that means this code was wrong because the largest number, so this initialization was wrong. So now we have to see how do we initialize this correctly to get the right answer. So how do we get it corrected? So instead of saying our largest number as 0, it is possible for us to give the largest number as number 1, which is 80. And from there on, we have to just repeat the same steps to get the largest number correctly. So anyone who just looks at this, your pseudocode, will be able to quickly point out that there is a mistake you have done. This largest number is equal to 0 has to be corrected, and then this has to be made differently. So especially when people do the reviews of the pseudocode, they can quickly point out these mistakes. Now that we have found the largest of these numbers, let's give a different problem. So here are some students and their corresponding marks. Now we have to get as the output what is the name of the student who has scored the maximum in the class. And input are student names and their marks, and then our process is to find out the top scorer. Though this problem looks very similar to finding the largest number, it is different in two ways. One, there can be more than one top scores in the class, right? For example, in this, both Deepa and Meena are top scorers. But our earlier problem was just to find what is the top score, which is 100. So that means the output is just not the name of one student, it's the name of multiple students. So what is the data structure for giving multiple top scores? So it cannot be just one name. It should be multiple names. So we might want to store that in a kind of data structure where we should be able to store one value or multiple values. So these are the considerations we have to keep in mind whenever we try to develop a program which may be similar to the previous one, but then there could be other exceptions or other conditions which might not be similar to the earlier problem. So why should you write your logic before you write your code? First and foremost, it's for yourself, for your own clarity. Whenever I do interviews, especially with freshers, I see that as soon as the problem is defined, they just jump into write their program without even thinking about what is the input, what is the output expected, and what should be the logic. If you have those things in your mind, you would be more clear about the problem you are trying to solve. So for yourself, make sure that you have written the input and output and the process clearly before you start writing your code. And next is for reviewers, for a little bit more complex problems than what we have defined earlier. The reviewers who is looking at your code will get a much better idea about what you are trying to write in the code by looking at your pseudocode. So in all the organizations, your seniors would review your code and give you inputs to make your code better. So to help them, if you have your pseudocode ready, you can explain to them about what you are trying to do. And obviously, all this would lead to avoiding rework. So once your program is written, there is no need to test it again and again, because it will be less error prone if you are writing your logic and you yourself are comfortable with it before you write your code. So let's do this exercise today. I've given a list of numbers. You have to write a pseudocode for generating the pairs whose sum is x. For example, if the pseudocode if you want the sum to be 10, so we should get pairs like 10 0 and 9 1, etc. So you have to get such unique pairs, and then you have to say how many such pairs are there in this. Don't write any program, just write the pseudocode. See you later. Bye.